Howdy, it's Ms. Kosh. I am here to talk about the Fibonacci sequence. There's a few reasons I want to do that. First of all is to give you an example of another type of sequence that's not arithmetic nor geometric. And second of all, to remind you some notation ideas. Okay, so the Fibonacci sequence, now the cool thing is I just Googled it. I Googled Fibonacci in nature, and here were some of the different images that just came up when I Googled Fibonacci in nature. And then I also noticed when I came over here and I looked for the videos, there's one here that looks interesting. I haven't watched any of it, but that's a 2.5-minute video that I might try and go watch at some point. We'll see. Okay, so this concept has some applications to the world around us, which I think is kind of cool. And look how pretty all of these things are. So I remember seeing a video that talked about this, that the number of spirals, if you spiral it one way, the number that you get is a Fibonacci sequence. If you spiral it the other way, you get an adjacent Fibonacci number. So now let's go talk about what the heck is a Fibonacci number. Okay, so with a Fibonacci number, I'm going to have some terms of my sequence. Maybe I should have written this ahead of time. I did not. Too bad. If they paid me more. No, I'm just kidding. Okay, so if my first term is 1 and my second term is 1, what we're going to do to find the third term is we're going to add the previous two terms. So 1 plus 1 equals 2. And so now to find the fourth term, I'm going to take the second term and the third term and add those together. So now 1 plus 2 equals 3. The fifth term comes from adding the third term and the fourth term, so 2 plus 3 equals 5. The sixth term, 3 plus 5 is 8. The seventh term, 5 plus 8 is 13. The next term, the eighth term, is 8 plus 13 is 21. Then the ninth term, that becomes 34. You'll notice that they start growing. I'm just having fun at this point. This becomes 55, is a Fibonacci number. It's a term of Fibonacci sequence. What happens here, well, so cool story. I had some kids a few years ago. I think they're now juniors in college. But when they were juniors in high school and had me as their teacher, after they had some downtime in class, I don't know how, maybe I didn't work them hard enough, but they put on big pieces of paper 100 terms in Fibonacci sequence, and they lined the top of my wall with Fibonacci. So after construction, I didn't have a chance to get it back up, but I still have all of them. So maybe one day I'll get all these terms of Fibonacci sequence on the wall. It looks pretty cool. Okay, that being said, what they found was the number of spirals here. I don't know if that's I'm guessing that's an 8. Pretend. Or then this one is 13. So if they went one way, they found 8 different, and that doesn't seem right. Well, maybe it is. I don't know. And then they went the other way. They found that there were 13 of those. And so notice 8 and 13 are adjacent Fibonacci numbers. There's other applications to this, but that is one thing that's pretty cool. So this one, if you try and write it, remember how we talked about how you can have a recursive formula, or you could have an explicit formula? The explicit formula looks something like, it's some equation where you can easily find the nth term. If it's arithmetic, it would be something like 4n minus 1. If it's geometric, it would be something like 4 times negative 3 to the n minus 1. That would be geometric. But it doesn't have to be. It could be something like, I don't know, 5n squared minus 6n plus 7. That would be an explicit formula to help you find the certain terms of your sequence. The recursive, do you remember what I always tell you with that? You have to tell me where to start, and you have to tell me what to do. Okay, so in this particular problem, well, not only do you have to tell me, notice we had said that this term plus this term equals that term, and then we said that this term plus this term equals that term, and so we needed 2 places to start for Fibonacci. So you have to tell me a sub 1 and a sub 2. Well, in this one, a sub 1 is 1 and a sub 2 is 1. So now to find any nth term, what I needed to do, so think about this for a second. Say I wanted to find the 10th term. I had to look back to the 8th and the 9th term. Well, how are those two related to this third one? Well, 10 minus 2 is 8, and 10 minus 1 is 9. So what we'll say to find our nth term is we need to do a sub n minus 2 plus a sub n minus 1. I don't know why. Anyway, n minus 1 is what that says. Okay, so keep in mind, if I were to write out all of my terms, I have my first term, my second term, my third term. Somewhere out here is the nth term. Well, what came right before that? Well, the a sub n minus 1. What came right before that? Well, a sub n minus 2. Okay, so that's 2 terms before the nth term. What would come after the nth term? Well, a sub n plus 1. What comes after that one? Well, one more past that is a sub n plus 2. So what I could do, actually, is I could say Fibonacci sequence is a sub 1 equals 1, a sub 2 equals 1, and a sub n plus 2. Well, what would that equal? That's this term. To get this term, I would take that one and add them together. And that's another way. This is a perfectly acceptable, perfectly legitimate way to describe Fibonacci sequence. Those of you that are interested, if you Google explicit formula for Fibonacci sequence, it will find like a sub n is equal to whatever. I don't remember it. I do know it has root 5 in a few places. So it's weird, it's kind of confusing, but it's definitely interesting for us. So be aware of this sort of notation. There's a reason I'm showing you this. So study, study, study for the quiz. Good luck. I wish you well. I have done everything I can to make it where there's nowhere for you to hide. That this is a chance for you to show me what you've learned and for it to be easy for me to grade but hard for you to do. So it's not impossible, but you're going to have to put in the work. So study, ask questions, let me know how I can help you. All right, goodbye, good luck.